So today we are graphing ellipses, which, for the lack of a better word, they kind of just look like ovals. Remember your circles when we were given these. Oftentimes we had to find the center. It wasn't at the origin. And you use the opposite of each of those numbers to get the center. And then we had to square root this number because that's really the radius squared. So the square root of 9 is 3. And then remember, after we graphed the center, we would just go out 3 each way. Okay? Our ellipses are going to be very similar. But our equations look a lot different. Okay? You'll still look here in the parenthesis to find the center. So the center of that would be 5, -8. So we come over here, 5, -8 would be here. Then, just like on the other side where you had to square root these to find the radius, the problem is, on an ellipse, it's not the same consistent distance. Like if you imagine this is the center, maybe this way you go out 3 either way, but maybe this way we go, I don't know, 8 each way, something like that. Okay? By the way, this longest part, you'll need that for later, will be called the major axis. And the shortest part will be called the minor axis. And that changes on the ellipses. Like here, that would be the minor. This would be the major. So it really just means longest and shortest. That's the easiest way to think about it. Okay? Major isn't always horizontal, isn't always vertical. It's just whichever's the biggest. Minor is the shortest. Okay, so over here, the numbers on the bottom, you want to square root those. So like the square root of 49 is 7. And technically it's positive and negative 7. Square root of 4, positive -2. Now, because that 7 is below the x, it means from our center, we're going to go out 7 to the right and 7 to the left. Since the 2 is below the y, you're going to go up 2 and down 2. And that makes your ellipse just as best you can. Try to make it rounded, look like a good oval, if you will. Okay, so I'm going to scan up so you can see that whole thing again. We found the center, we square rooted those, we just went out either way. And that's a good ellipse. Okay, here's a new equation to graph. Remember that we start by finding the center. And if there's no number here, that means the center is 0, 2. So 0, 2 would be right here. And then we're going to square root this. And the 36. Okay, so on the x-axis, we're going to go either way 5 from the center. On the y-axis, we're going to go up and down 6 from the center. Okay, now I've unfortunately drawn this right in the middle of my problem, so hopefully I won't cut out too much. Now this one's kind of a hard one to draw. You want to round it a little bit. Yeah, that looks awful. Okay, what you should notice, by the way, is the closer these numbers are to being the same, the more your ellipse looks like a circle. In fact, if these were both 5s or they were both 6s, this would be a circle because that would mean that the radii would all be the same. So ellipses are really just like circles that have different radii each direction, if you want to think of it like that. Okay, last thing on this homework, I'm not going to make you do all 8 of the graphs, So here are the 4 that I want you to do. This is the front page, and I believe this is the back side of the back page. It might be the front side of the back page. I tore mine apart already, so I can't remember. Okay, so just do those 4 problems, and then, you know, like you did on the other one, just kind of lay it out like that so that I can see a picture of it done. So just do those 4 for homework and email it to me.